All right, hopefully you guys had a good day. Ready to begin. We're going to rational equations here. So 1 over n minus 8 minus 1 is equal to 7 over n minus 8. There's two ways to really solve rational equations. First of all, you could multiply through by a common denominator. Or, number two, you could just create common denominators. And that's what I'm going to do in this situation. I'm going to create a common denominator. What would be the common denominator? N minus 8. You see that the first term is fine, 1 over n minus 8. But then I'm going to take the 1 and multiply top and bottom by n minus 8 over n minus 8. And you see you have 7 over n minus 8. Any questions how we got that? If the denominators are the same, then we can just work with the numerator. And so we have 1 minus the quantity, n minus 8, is equal to 7. Distribute the subtraction sign. 1 minus n plus 8 is equal to 7. Or negative n plus 9 is equal to 7. Or negative n is equal to negative 2. Thus, n is equal to 2. Now, you might recall that when you're solving rational equations that you need to be careful about your answer in the end. We just have to make sure that when we plug in 2, that we get a defined result. What is the one number we could come up with that when we plug it in, we get an undefined result? 8. If you came up with 8, that would be problematic, wouldn't it? Yeah. Okay. Letter B, what's your common denominator there? Yep, or x times x plus 2. So we're going to look at the left side and multiply top and bottom by x times x plus 2. We have 1 over x times x plus 2. And then I have to multiply top and bottom of the last term by. Yep, x plus 2 over x plus 2. Notice now they all have the same denominator, which is x times x plus 2. So I multiply this out. I have x squared and 2x. I have 1 plus x squared plus x minus 2. If I have a second degree equation like this, what do I do to solve? What's your approach going to be here? Yeah, very good. Gather everything on one side, so you set equal to 0. So we'll start moving our x squareds over. So we're going to subtract x squared from both sides. And see that those go away. We get 2x is equal to 1 plus x minus 2. Subtract x, we get x is equal to negative 1. That is a valid solution. If you plug it back in, it should work out. Are there any questions to solving those rational equations? I'll be honest, that's where your brain starts to go to mush on the test. You start to see fractions. You're like, I don't know what I'm doing. So make sure you practice this in your assignment today. What about letter C? Yeah, if you simply just, that would be the common denominator. But if you have a fraction equal to fraction, just go across multiply. Subtract the 6. 0 is equal to x squared minus x minus 8. Is that factor? Oh boy, what do we do? Quadratic formula. You all remember it, right? Did you learn to sing it? Will somebody sing it for us right now? Espy, go ahead. Wow, that was, give her a round of applause. That was exceptional. She showed a lot of courage here by just, she didn't wait at all. She was ready for that. I asked the other hours and they did not. And then when I decided to say it, they made fun of me. I would agree. Apparently, I'm not very good. I didn't claim to be good at singing. Claim to be good at math, but that's it. suck at everything else. Okay, here we go. X is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. You will never get that on a test. I will never give it to you. You must remember that 100% of the time. Okay? Commit it to memory. Figure out a way. So I have x is equal to negative b is positive 1 plus or minus the square root. B squared is 1 minus 4 times 1 times negative 8 divided by dos, which is Spanish for 2. 1 minus 4 times 1 times negative 8. What do you think? 33. Because we add the opposite and you get 1 plus 32 is 33. That's what Alex was thinking. That's what Miss Caitlin confirmed. You cannot break down the square root of 33, so you are done. Those are your two solutions, 1 plus and 1 minus. How do you feel about that? What if we have radical equations like letter yes? Oh, this negative up here? Got it now. Good question. Thank you for asking. All right, square root equal to that. We just square both sides. We get 2x plus 1 is equal to 9. Subtract 1, 2x is equal to 8, so x is equal to 4. Should always be careful if you ever square both sides. Sometimes you add a solution that does not exist. You should always plug your answer back in. So if I do square root of 2 times 4 plus 1, do I get negative 3? No. You don't. You get 3. You plug it back in, it doesn't work. You see, folks, if you take the square root of a number, square root of 64, we say that that's 8. We don't say square root of 64 is equal to plus or minus 8. If you're solving an equation, you say x squared is equal to 64, and you know you have two solutions, then you say plus or minus 8. But if you're just taking just a regular square root of a number, like in this case, when you took the square root of 9, you get 3, not negative 3. So in fact, there's no solution here. Now, I'm not going to try to give you a situation exactly like that, where you come up with a, something tricky. But I do want you to be aware of the possibility of getting those no solutions, even if they come up as a solution ahead of time. So E looks really complicated. What would we do there? Yep. So I add the 3 over, and we get the square root of x plus 1 is equal to x plus 4. Square both sides. Again, we run the risk of adding a solution that doesn't work out, so we have to be careful. We square both sides, and we get x plus 1 is equal to x squared plus 8x plus 16. Now what? Gather terms. 0 equals x squared plus 7x plus 15. Factors, right? Ugh. Okay, doesn't factor. Quadratic formula. Fortunately, it's really not that big of a deal. Negative 7 plus or minus. Now my smart board is mad at me. Wait for it to get itself figured out here as you guys work through the problem. I got good news this weekend. I'm getting my roof replaced. Fell under insurance. That's good news. Yes. Square root of 49 minus 4 times 1 times 15. All divided by 2. What do you notice about the discriminant here? This is the discriminant, the part underneath the square root sign. What do you come up with? A negative. Can you take square root of a negative? No. So that means you have two imaginary solutions. Now, how you list this on the test, you could write it as negative 7 plus or minus the square root of negative 11 over 2 and say, it's non-real. Or you could write it as negative 7 plus or minus I roots of 11 over 2. Either way, just indicate to me that there are no real solutions. The solutions are what we call non-real or imaginary. If you don't express it exactly like negative 7 plus or minus I roots of 11 over 2, I'm not going to count that wrong on this test. In chapter 3 I will, but not right now. Try letter F on your own. I got 61. Do you got 61? If you plug it back in, it does work into the equation, so we know we're good to go. That is a review of rational and radical equations. Good? Okay. The next two pieces, we do example 5 and example 6, not example 7. Example 5 and example 6 were done, so we have 8 problems left to get through. You guys are doing good with time here, but here's the piece. It says use quadratic form, not the quadratic formula. It says use quadratic form in order to solve the following. Now, you've used quadratic form in the past, but you maybe just didn't understand it. Let's understand what quadratic form means first. If I write the word quad, what do you think of? What number comes to mind? 4, right? Yet, we say that that's quadratic. Does that ever bother anybody? It's got 3 parts to it. Sounds like try to me, right? And it's got a square. That would seem like, you know, not quad. That didn't bother anybody. Nobody. Carson? No. Does it ever bother you that you drive on a parkway, but you park on a driveway? You park on a driveway, but you drive on a parkway. That bother you? Hmm. How about the fact that they have Braille on ATM drive-up machines? Ashton, are you at all bothered by this a little bit? Yeah, okay. They're okay, exactly. Or you've wondered things like if a fly didn't have wings, would it be called a walk? Probably. So this bothers me. Quad, yet we've got x squared minus 2x minus 3. Here's why, folks. It factors to x minus 3 times x plus 1. Agreed? And if you multiply it out, you get how many terms? That's why they call it quadratic. Because it multiplies to 4 terms before you combine it together. That's why. So, same can be said even if it's not to the 2nd degree. That's to the 4th degree. So, we're going to write this as x squared and x squared. What are two numbers that multiply to 36 but add to negative 13? Negative 9, negative 4. Does that factor? Yes. X plus 3, x minus 3, x plus 1, x minus 1. So what are my solutions? What did I do? Oh, 2, thank you. Stupid kids. So x is plus or minus 3 and plus or minus 2. We have 4 solutions. So even though it's not the 2nd degree, sometimes you can still use factoring to solve. 3x squared and x squared. What else? Minus 1, minus 1. Looks like that second one, x squared minus 1, is going to be much easier to factor, right? X plus 1 times x minus 1. So x equals plus or minus 1. But this one is a little bit more challenging. 3x squared minus 1 is equal to 0. Or 3x squared is equal to 1. I'm not factoring it. I'm going to use square roots to solve this. Divide by 3, x squared is 1/3. Now I could square root both sides. X is plus or minus. Square root of 1 is just 1. Square root of 3, can you leave the square root of 3 in the denominator? No. So it's X is plus or minus, multiply top and bottom by the root of 3, you get root of 3 over 3. So those are your 4 solutions. What's different about the next one? Does that make you angry? Okay. No way to get rid of the fractions, but it does go x to the 2/3 times x to the 2/3. Good. Minus 4 plus 1. Now when you get x to the 2/3, minus 4 is equal to 0, you know you add the 4 and get x to the 2/3 is equal to 4. But now you're worried, how do I get rid of an exponent of 2/3? What do you think? You're going to take it to the reciprocal power. Let me help you understand why. If you have a power to a power, what do? Multiply. What's 2/3 times 3/2? 1. See how you just get x to the first power? What's 3 cubed? Square root 8. Try next one. X to the 2/3 plus 1 is equal to 0. Or x to the 2/3 is equal to -1. How do I get rid of the 2/3 power? Raise it to the 3/2. Again, I'm not multiplying by 3/2. I'm raising it to the 3/2. I get x is equal to, what's -1 cubed? -1. What's the square root of -1? I. Very good. It's only funny when Lexi does it. I agree. So, non-real solutions there. Here we get 8. You try letter D on your own. It's x to the 1/2 minus 5x to the 1/4. That's how you start off. You got to rewrite it so it has rational exponents first. See if you can make any progress with that. Talk to your buddies around you. See if you can start something. Try it. All right, let's see what you got. Okay, so I'm going to have x to the 1/4 times x to the 1/4. Because 1/4 plus 1/4 is a half. Well, there are two numbers that multiply to positive 6 by adding -5. Good. So x to the 1/4, x to the 1/4 minus 2 is equal to 0. So x to the 1/4 is equal to 2. So you raise each to what power? What's 2 to the 4th? 2 times 2 is 4, times 2 is 8, times 2 is 16. Same thing over here, we'll get x equal to 3 to the 4th. What's 3 times 3 times 3 times 3? 81. It's good. Yeah, you guys made some progress on your own with that. Good job. Way to go. Okay, 6 and 1, great. Yeah, that's a very common problem. People see the 6 and the 5. You know, you come up with 2 and 3 or 6 and 1, and sometimes you make the wrong choices. So don't feel bad. That happens every year. People make that mistake. About a third of the class did that last hour as well. So don't feel bad. All right. All right, you made it through the most difficult stuff. You ready for the easy stuff? 4 easy problems, you're done. These are literal equations. Literal equations are where we're solving for a variable amongst other variables. So it says solve for c. I'm going to divide by m. So I get e over m is equal to c squared. Now what? Square root. So you get square root of e over m is equal to c. Now some people get upset about this. They're like, you should list the plus and the minus. Well, understand that this is an equation from Isaac Newton, right? Energy equals mass times constant squared. Einstein, excuse me, did I say Newton? Oh, wow. How silly of me. So anyway, he knows whether or not the constant should be positive or negative. So in context of the problem, you may not have to list both positive and negative. Second of all, some people get upset that you have a square root in the denominator. It doesn't really matter if you have a square root of a variable in the denominator. We just get upset if you have a square root of a number in the denominator. So this is fine. So this one I want to solve for m. I'll multiply both sides by q squared. Rq squared is equal to t times m times g. Solve for m, divide both sides by t times g. Sweet. 2 more examples, and these are a little bit trickier. Okay, you guys have identified that this one's more difficult because you got x's in 2 different places. So I'm just going to cross multiply to get 2px minus 2r is equal to 3rx minus 12. Is everybody okay with that step? Now, what I'm going to do is I'm going to gather all the x's on one side, and everything that doesn't have an x gathers to the other side, even though you can't combine them together. So 2px minus the 3rx, so I subtract that 3rx over, but then I'm going to add the 2r to the other side. It's imperative that everybody is okay with what I just did before we move on. Y'all good? So this is the aha moment, the big question. How do I isolate x? How do I get x by itself? These are really good thoughts. Ooh, this group needs a hint. Starts with an F, rhymes with actor. Factor. Factor what? What can you factor out? Factor out the x. And I factored the x out. Now it's isolated. See how it's by itself? So how do I solve for it? What do I have to get rid of now? Yeah, just divide the 2p minus 3r. What do you think? Did anybody put the x's on the other side? Okay, then this is the last question. What if I got this as my answer? Are those two equivalent, or are they different? Would you agree that the top and the bottom are both different by a factor of -1? -1 divided by -1 is 1. So if you would have put the x's on the right-hand side, you would have come up with this. X's on the left-hand side, you come up with this. Those are the same because the top and the bottom are different by a factor of -1. Good work.